Okay, example 2 in finding zeros of a polynomial. The first step is finding the possible rational zeros using the rational zero theorem. So I want to find my possibilities. I'm going to take all the possible factors of my constant. Since my constant is 3 or negative 3, I have 3 and 1 as my possible factors. And then my leading coefficient is 1. So my possible factors of the leading coefficient is 1. Now when I list out all my possibilities, I have plus or minus, and then I have 3 over 1 or 1 over 1, which would just give me plus or minus 3 and plus or minus 1 to check. Okay, so I have 4 to check. When I plug those in and see which ones actually give me 0, I'm going to find out that negative 3 is a 0. When I plug in negative 3, I'm going to get out 0 for my corresponding y value. Okay, so now I know since this is degree 3, I should have 3 zeros. I only have 1 so far. So I've got to break this down further. I have to go through more steps. So since I know negative 3 is a 0, then I'm going to use synthetic division to break this down and factor it. So my coefficients of my polynomial are 1, 7, 11, and negative 3. So I'm going to bring down the 1, and I have negative 3 times 1 is a negative 3. The 7 and the negative 3 gives me a 4. Then I have the negative 3 times the 4, that gives me a negative 12. And when I add those up, that gives me a negative 1. And when I take negative 3 times negative 1, that gives me a positive 3, which gives me a remainder of 0. Now, we should always have a remainder 0 if I know the value that I'm dividing, or that divisor, is an actual 0. So now I know, since negative 3 is a 0, I know I should have the factor x plus 3. And this is my other factor then. So I have x squared plus 4x minus 1. Now this won't factor over the rationals the way that we know how to factor, by finding the combinations of negative 1 that would add up to 4. We can't do that in this case. So then to break this down further, what we're going to do is use the quadratic formula. Since it is a quadratic, I can use the quadratic formula to break it down. So I'm going to have minus b, which is minus 4, plus or minus the square root of b squared minus 4ac all over 2a. So that's 2 times 1. So that gives me a negative 4 plus or minus. When I clean up what's on the inside of that, I'm going to get a 20 over 2. I can rewrite the square root of 20 as 2 square roots of 5. And then I can simplify it and take it one step further by dividing everything by 2. So when I take 2 into negative 4, that gives me a negative 2. And when I take 2 into 2 square roots of 5, that gives me just the square root of 5 left. So now I have my 3 zeros. So we found the first one using the rational zero theorem. That was negative 3. And then we found the second two, or the last two, by using the quadratic formula. So that's minus 2 plus the square root of 5, and minus 2 minus the square root of 5. Now these are all real numbers. So all of these are additionally going to be x-intercepts. So when I look at the graph, this is where it's going to be crossing the x-axis. Now it's a little bit difficult to visualize where negative 2 plus the square root of 5 is on the x-axis and where negative 2 minus the square root of 5 is on the x-axis. So what you can do if you want to visualize that, you can put that in decimal form, and that should be about 0.24, and this would be approximately negative 4.24. So when you look at this graph, it's going to look like this. Let's see if I can draw this. So this point right here would be the negative 4.24. Then this would be the negative 3. And then it would cross then at 0.24. It's not scaled very good. I'm not a very good artist. But it will have this general shape, and it will cross at those 3 places.